Hey everyone, welcome back, and we are here to take up our work from last week. So we are going to start with question 8. So if you notice question 8, there are a few parts to it. The first part we have is top right, the stem and leaf. So when you deal with a stem and leaf plot or a graph, it's just a way of organizing numbers and data. That's all we're using that information for. So you were given 14 values, okay, ranging from 8 to 125. So the stem will always be our tens and above, okay? And our leaf will always be the ones digit when you're given a two-digit number. So our first number we deal with is number 8. That's our leaf because we don't have the tens. But the other numbers we do. So we have numbers such as 27, 35, 36, 37, 39, etc., etc. Okay? So the tens value goes in the stems column and the leaf will contain the ones. We also arrange the leaf in order from least to greatest, and we also will arrange the stem descending or going down from 0 to whatever numbers we have. Okay, so in this case, you can see that a stem goes from 2, 3, 4, 7, 12, and the leaf values are arranged in 0 and in order from 0 to 9. If you look at the 40 numbers, we have 40, 41, 44, 47, 47, 48. We will always include each value that we have for each number. Okay? If we have two 47s, we include them. And lastly, 125. If you notice, our stem is the 120 part, and our leaf is the 5, or the single or the ones digits. Okay? So that's what your chart should look like. Then we have the formulas for mean, median, and mode. So there's our mean formula, the sum of values divided by the total number of values. So you will add all of these up, okay? And then you will divide it by the total number, which is 14. And you should get 46.29 as a mean. Now the median, on the other hand, remember, there's two ways of calculating it. So for the median, if you have um, an odd number of values, then that's simple. Just look for the middle number. But in this case, we have 14. So what you're going to look for are the two middle numbers that separate the data. So we have, in this case, 6 on either side. So if you look at our numbers, we realize that 40 and 41 are our two middle numbers. Okay. And we are going to divide that by 2 to get 40.5. Of course, the mode is the number that occurs most often. And in this case, it's 47. Okay. So our outliers, we have our 8, 74, and 125. These are three numbers that really don't tend to be centered around the rest of the numbers. Okay. In other words, they're kind of like out there. Okay. So if we were to throw those three numbers out, we realize that our mean is now going to be 40.1. So that's a big difference between 46 and 40. Okay. So that's how outliers kind of influence our values. Question number 9. So you had to draw a circle graph, and well, there's my really rough sketch of a circle graph, but you kind of get the idea. Okay. The big chunk of the circle graph will be 165 degrees or 0 to 10. Okay. And now remember, um, you need to calculate the total number of minutes, or students in this case, and you divide each section total minutes by the overall total. Okay, and then you're going to multiply that by 360 to get the number of degrees you get for your pi. So you should have something that looks like that, right? So two really large sections, pi, and then increasingly or decreasingly gets smaller and smaller. Okay, and your answer for B is about 160 students. Okay, so here we are. We have question 10. Okay, your circumference, 10a, your circumference is basically 2 times pi times r. Right, so you just substitute those values in for the variables, and you should get 75.36. Of course, our area is pi r squared. That's our formula. So our radius is 12. We square that to get 144, multiply that by 3.14, which is pi, and we get 452.2 centimeters squared. Okay, so 10b then, they give us a diameter of 6. So of course, half a diameter is 3, right? So that's our radius. So 2.314 times 3 gives you 18.84. And then we use the same formula for area, pi r squared, right? Our r value is going to be 3. So 3 squared is 9. 9 times 3.14 equals 28.26. Okay, so in this situation, you need to know your formulas. So of course, a quick Google search would do that, or if you look through your notes, you would find that. Okay. So now circumference in A is 4 times as great as circumference in B, right? So 18 times 4 gives you roughly 75, 76. Okay. So that's how I calculated that. And then your area is basically 16 times as great, right? So if you wanted to, you could divide those two numbers and you would get something like 16 decimal something, okay? So that's how you can calculate that. You can eyeball it, right? You know that 28 times 10, for example, this is 10D here, if would be 280, okay? And then 6 times 30 is 180, right? So that kind of, you can kind of do it that way if you wanted to. But probably, you would do some playing around with the numbers to determine those two answers for C and D. All right, so question 11 dealt with a tuna can. Yay, exciting times. So if you wanted to, you could have, gone to your cupboard there and get yourself a tuna can and cut the paper around it in half and unroll it, and you can do some math that way if you wanted to. Or once again, you need to know your formulas. So in this case, we're looking for the volume. Okay, so I drew my picture. I knew that the height is 3.5 centimeters, and I knew that the diameter of my can was 8.5 centimeters. So my volume of a circular cylinder here, I'm trying to use my new words today, is as shown, V equals pi r squared times height. Once again, I substitute my values in there. Okay, so 4.25 squared does not mean 4 times 2, it means 4.25 times 4.25. Do all that math, you get 198.5 centimeters cubed. The cubic is important, the little small 3 is important because that tells me it's volume. Now to find the area of the label, that is a little bit tricky, okay? So we know that the height is 3.5, and if you look at my picture to the right there, okay, that one there, I've kind of shown you that. So if I were to cut that label and unwrap it or unroll it, it kind of looks like a long rectangle, doesn't it? So I know my height is 3.5. I don't know what my length is, okay? But if I were to kind of reattach that, so in other words, get that long rectangular piece and enclose it so it becomes a circle, my length is actually the circumference of the circle. So that's going to help me, okay? And that's why I'm using that down there. Circumference equals pi d, 3.14 times 8.5, okay? To get 26.69. So that's important because that's now my length of the rectangle. So then we come down to the bottom here, and then I just plug in my values. My area of a rectangle is going to be length times width. So 26.69 times the height, which is 3.5, and I get 93.42 centimeters squared. Alrighty, here we are, last question. So this is going to incorporate that you understand a bit about angles and angle relationships and angle theory. Okay, so I have 2 lines at the top there. Basically, they are parallel lines, even though I haven't indicated them. They're going in the same direction. I have a trapezoid shape, plus I have a triangular shape attached to it. Okay, so I need to find A, B, and C. And I also know that I have some dimensions given to me, don't I? I have an interior angle of 7. The triangle has an interior angle of 128 and 10 degrees. Okay, so I also know that in a triangle, there are 180 degrees, don't I? Right, so this is where the line and the angle relationships that we did this year come into play. So to find out what A is, my answer is 52. So what I did was I knew that a straight line equals 180. Well, if you notice, I have a 128 degree angle there. 128 subtracted from 180, right? Because A plus 128 equals 180 tells me that A is going to be 52. 52 plus 128 equals 180. So that's how come I get A equals 52. Now B. So I'm thinking back to my interior angle relationships here. Okay, my angle relationships. I have two parallel lines. I know that co-interior angles, or the C pattern, if you remember, is the angle, the two interior angles equal 180. Well, I know that 70 is one of them. So what's B? Well, if you see, I have kind of calculated it using 70 plus B equals 180, right? Do some algebra, get rid of 70 from both sides, and 180 take away 70 would give me 110. Lastly, how do I calculate C equals 138 degrees? So I know that in a triangle, there's 180 degrees, okay? I've been given two angles, 128 and 10. So that equals 138. So therefore, I subtract 138 from 180, and I get the other interior angle, which is 42. Now I need to find the C value. Okay, so I have been given all this information. My missing interior angle there of the triangle is 42. So therefore, I'm going to, if you notice down here at the bottom, set up a little algebraic equation. C plus the missing angle equals 180. I know my missing angle is 42. So I'm subtracting 42 from both sides, and I get C equals 138. Okay, so there you go. Using some angle relationships and line relationships and triangle theory to calculate the missing angles, A, B, and C. That's it for today. Okay, take care.